The curve C has equation y equals to 9 minus x squared. Use algebraic integration to find the area of the finite region bounded by the curve and x-axis. So it's better if you can draw it first, then you won't have any confusion about the limits and whether you are considering the correct area. I mean, whether you're finding out the correct area or not. And its quadratic equation is very simple. Y equals to 9 minus x squared. So minus x squared plus 9. So we know that in a quadratic equation, if the coefficient of the x squared term is negative, in that case, the graph will have a maximum value. The graph will have a maximum value. But if the coefficient of the x squared is positive, the graph will have a minimum value. We know about it. So as the sign of the x squared is negative here, so the graph will have a maximum value. And the y-intercept is plus 9. So the shape is going to be like this. 0, 9, that's the y-intercept. And if you want to find out the x-intercept, we will consider the value of y as 0. So that's x squared equals to 9, x equals to plus minus 3. So this is minus 3, 0. This is 3, 0. If you want to find out the area, we know that area under a curve, that's y dx. Area between the curve and the x-axis, that's integration of y dx. Lower limit is 3, lower limit is minus 3, upper limit is plus 3. Upper limit is plus 3. So now just use the formula. So the answer is going to be 36. 36 units square. So that simple calculation, just use the formula. Integration of dx, that means x, and here integration of x square means x to the power 2 plus 1 divided by 2 plus 1. I mean, you need to know about the basic integration, otherwise you won't be able to solve it. So solve the basic integration maths first, then do the integration related questions from the book, then solve question papers. So I think you have understood. So let's move on to next question.